So for electric motion, that this problem, okay, we starting with the AS graph. We know AS graph instead of VS, okay, and we would like to construct VS graph, okay, and then according to this, if we would like to construct VS graph, it's not the same as AT and ST and VT. That we just direct integration and we got that. So for this case, we have to use this relationship ADS equal to VDV. And after that, we can construct the VS graph from from this information from AS graph. Okay, so let's take a look. So for this case, I have the solution already. Okay, so from AS graph, that we know just only the graph. So then we have to determine some information. For example, that the first part from S equal to 0 to S equal to 10. We found out the graph, the AS graph is linear. It's the linear function. And what is that function? So then we may use two coordinate. This is coordinate. The first one, that is the starting from origin, that is x equal a equal to 0 at s equal to 0, right? And then at the end point, we found out, and when s equal to 10, a equal to 10. So we may use the basic knowledge for mathematics, as we already know the relationship of the linear function. That is, we know that the linear function is y equal to mx plus c. So then we have two coordinate. We can determine for the slope. And after that, for the slope, that is mean that it is the m. And after that, we can find out the function for this is equal to a equal to s. This is the function for the first part. Okay. And for another part, this is constant. It is constant. A equal to 10. Okay. So according to the relationship, VDV equal to ADS, we integrate both sides for the range of S from 0 to 10 meter. And after we integrate both sides, we obtain the relationship of V equal to S. Okay. We obtain the relationship of V equal to S. So then for the first part, we can plot the graph, VS graph, that is the linear relationship, like this. And we can substitute for S equal to 10, V equal to 10 also. But after that, for S greater than 10 meter to 15 meter, okay, we use the relationship of VDV equal to ADS again, and we integrate both sides. And at S equal to 10 meter, V equal to 10 meter from the initial value before the second part. Okay, we integrate both sides and we found out we have this relationship and we have this graph. Okay, we have this function V equal to square root 20s minus 100. Okay, we have V equal to square root of 20s minus 100. Okay, so it is not linear function. It is a curve. This is a curve, but its curve, the curve is in which direction? Okay. So we can determine the point at the end point. We know that for S equal to 15 meter, we substitute and we got that we become 14.14 meter per second. Okay, but the curve is not linear. It's not the straight line. It is a curve. So how can we know that it is the curve is in which direction? Is maybe it's in this way or in this way. Okay, so we may consider the curve by take the derivative, take the first derivative to this. Okay, and we found out after we take the first derivative to the function dv by ds, we obtain the solution of 10 minus 20 s minus 100. So does it mean for this case is mean that if we consider this function that is the slope of the graph, we may find out when s is increases, okay, from this function, dv by ds should be decreased, okay, because s is the divisor. Okay, so when s is increased, dv by ds should be decreased. So what does it mean? It means that the graph it should be in this trend. Okay, so the curve it should be like this. Okay, so that's why I plot the curve and I mentioned that it is the curve. It is the curve. It is not linear, but because the curve, this part is very close to the linear because it's a little curve for this range. Okay, so when you plot the graph, okay, if you found out the problem is become like this, and it's maybe makes the reader confused that it is should be the curve, you may mark that it is a curve, and as the function is something like this. Okay, and it may be better for show your understanding of the solution. Okay, so for this problem that it should be complete. Okay,